Alright, so we have 3 goals today in this video. The first one is that you can construct and interpret categorical data in a bar graph or pie chart. So our verbs or our actions are to construct, which is to make, and interpret, which is to look at something and gain information from it, and categorical data, which is data that fits into categories, not with numbers. And we're going to be talking about bar charts and pie charts today. Our second goal is to compare the strengths and weaknesses of each type of statistical graph. That's going to be an objective throughout this week. Today we're going to focus specifically on bar graphs and pie charts. And then the third one is to identify what makes some graphs of categorical data deceptive. Alright, so these 2 problems and then on the next page problems are what you're going to have to do to show mastery of those 3 objectives for today. So you're going to be given a bar chart and you need to extract some information. You're going to be given a pie chart and you have to extract some information. For this section of 1.1 Day 1, these are the vocabulary words that we're going to be exploring throughout this lesson. So if you want to write those down, we will be giving definitions to them throughout the lesson. Alright, so for some of you, last week we did those graphs, so this data may be familiar to you, but these are our whole class's Algebra 2 grades. So if you notice, we're talking about letter grades, so we're not talking about numbers. So what we're going to do is from this information, we want to extract these 4 pieces of information. So individuals, identify the variables, identify what categorical means, and then univariate. Alright, so the first question is about individuals. So individuals are the objects described by a set of data, and it's always a noun, and generally in statistics we talk about people. Sometimes it's objects like things, sometimes it's animals, but for the most part it's going to be about people because that's what we study is people. So in this case, the individuals who are represented by these letter grades are our students. So the variable is any characteristic of an individual, and it's what's being measured. So when I look at this data, A, B, C, those represent grades. Alright, and then this data is categorical because you're placed in a specific category. So if you got an A, you're in the A category. If you got a B, you're in the B category. So this is categorical data, and it's univariate. So when I hear the word univariate, I hear uni, which a unicycle 1, and variate is a variable. So that is something that's measuring one variable. So if our variable is Algebra 2 final grades, we're only measuring that variable, so it's univariate. If it were bivariate, we might be measuring you're studying over time. So we're looking at 2 variables, time and studying, which in all of your algebra learning, we had an X and a Y axis. So we had 2 variables that we were talking about, so that would be bivariate data. Alright, so we are going to create a bar graph. That's the first part of our objective, is to construct a bar graph. So a bar graph depicts categorical data in bars that represent raw numbers or percentages. So we're actually going to make 2 bar graphs. We're going to do one where it's the raw data and one where it's the percentages. So the distribution tells us what and how often a variable takes a value. So when I look at this, I need to decide on the distributions first. So the first thing that I need to do is determine the distribution. So I'm going to look at how the grades break down. So I have A's, I have B's, and I have C's. Alright, so I'm going to count how many A's I have. So 1, 2, 3, 4, 5, 6, 7. So there are 7 A's. The distribution of A's is 7. B's, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I have 11 B's. And then C's, 1, 2, 3, 4. Which I want to double check. 11 plus 7 plus 4 is 22. And I have 22 students that I had Algebra 2 grades for. So that adds up. I always want to double check that. So now that I know the distribution, I can create categorical data in a bar graph that represents those raw numbers. So I'm going to come over here and I'm going to make my two axes. So on the x-axis is going to be the variable that's being measured. So A, B, and C. And then on the y-axis is going to be the frequency, because this is univariate, so we're looking at how does that one variable how does it take on those different distributions, those different values. So I see that the highest I need to go is 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And I want to make sure that those are as even as I can get. Obviously, if I were drawing on a piece of paper, it's going to look a little better. And this is letter grade for Algebra 2. And then this over here is going to be frequency. And for some reason, when I record this, I can't get over there completely, so I'm going to write frequency right here. But that should be happening over here. All right, so now I make my bars. So I had 7 A's. I had 11 B's. And I had 4 C's. So I can see, better than looking at a list of the data, I can see that most people got a B in Algebra 2 last year, or the year before if you took it the year before, but in Algebra 2. So now let's turn these into percentages. So I want to look at the distribution based off of a percentage of the whole. And the reason we would want to do this is if I were comparing different bar graphs that had different people. So let's say that I was looking at just our class, so that's 22 students, and then I made a bar graph of all of Austin East students' Algebra 2 grades. Well, obviously our class only has 22 individuals in there, whereas all of Austin East might have 400 students who have taken. So when I look at A's, I'm going to have way more than just 7 A's, so it's really hard to compare. So if I turn those into percentages, so what percent of students got an A out of the whole, I can then compare those two graphs a lot easier. So I said there were 22 possible students, so 7 out of 22 is going to be 7 divided by 22. And I get 31, we're going to round to 4 decimal places, so 0.31818 becomes 31.82%. And then 11 out of 22 is half, so that's 50%. And then 4 out of 22 is 0.81818, so that's going to be 18.18%. So now instead of graphing the raw data, I'm graphing the percentages. So I'm going to have the same XY axis. I'm still going to measure A's, B's, and C's. And now I'm going to talk about the percentage. So I'm going to go, I need to go up to 50%. So I'm going to say 10, 20, 30, 40, 50, 60%. So now this is where it's really important that you label your axes, because this no longer means 10 students, this means percent. Alright, so my A's were 31.82, so I'm going to be a little bit higher than 30. My B's were 50%. And my C's were 18%, so it's just going to be a little bit less than 20. So if you notice, these two graphs take on the same shape, where it goes up and then it goes down, and I can see that B's are the most common, I can see that A's were the second most common, and then C's were the least common. So that is how you make a bar graph using both raw data and percentages. Alright, so we're going to interpret. So we constructed, but really on a multiple choice test, you're going to be interpreting more than constructing, but we need to understand what goes into that. So this is actual data. The National Student Clearinghouse keeps track of students post-secondary, so after high school, how they do. And so if you look, this is the 2008 class of Austin East seniors, the 2009. and there were 173 students in the 2008 class and 179 in 2009. And then what this shows is how many students graduated with a college degree within 6 years. So one person graduated in 2 years or less. So if it's 2 years or less, it's probably an associate's degree. 3 years could be associates, could be bachelor's if they worked really fast. Graduated in 4 years. Graduated in 5 years, and graduated in 6 years. So 6 years might be a master's degree, or it may have taken 6 years to get your bachelor's degree. So I want you to just look through these questions. Go ahead and pause the video, and I want to see if you can come up with the answers to those questions. All right, so you may have found that just looking at raw data was really hard to interpret from a table. So that's why we create graphs, because graphs help us see things a lot faster and in comparison. So let's go ahead and let's look at 2 graphs of this same data. All right, so this is called a stacked bar chart, and what a stacked bar chart does is it takes percentages and it stacks them up on top of each other. So when I look at the blue is 5%, but I can see the blue, which represents graduated in 5 years, but I can also see, including the blue, the orange, the green, and the red make up about 11%. So that shows me that 11% of the class of 2008 graduated in 5, 4, 3, or 2 years or less. So a stacked bar chart sees part of the whole. So now let's look at these questions and see if we can come up with the answers. So is this data displayed in raw numbers or percentages? Well, I can see over here that we're talking about percentages. What percent of the class of 2008 graduated from college within 6 years? So all of the bars are 6 years or less. So I can go over and see that just a little bit over 16% of the 2008 earned a college degree within 6 years. What percent of the class of 2008 graduated from college? Oh, that should say 2009, I'm sorry. Graduated from college within 6 years, and when I go over, I can see it's a little bit, so half would be 11%. So it's a little bit more than 11% of all of the class of 2009, that should be 9, within 6 years. Which year had a higher percentage graduate from college within 4 years? So we're going to compare orange, green, and red comparison. So orange, green, and red, we're talking about here, orange, green, and red here. So I can very visually easily see that the class of 2008 had more student, or had a higher percentage graduate from college within 4 years. Which year had a higher percent of students graduate in 6 years? So we're looking just at 6 years. So 6 years is going to be the yellow. So 2008 had 5 and 2009 had 3. So I can see that 2008 had a higher percentage of students graduate in 6 years. And which year had no one graduate in 3 years or less? So 3 years or less is going to be the red and the green. And I look over here, and 2009 didn't have anybody graduate any sooner than 4 years. So that's how we interpret a bar graph. All right, and our final objective with specific graphs is to be able to compare the strengths and weaknesses. So some of the advantages of a bar graph is it's easy to see trends. You noticed better than tables, we could identify that information. You can summarize large sets of data. So 178 people is a lot of people, or 500 people is a lot of people. So a bar graph allows me to summarize a lot of data versus a dot plot that would take a lot of time to plot 500 dots. They're easy to make. They're easy to understand, and you can show raw data or percentages. So some of the disadvantages is that people can manipulate them to make them look a lot different than they actually are, and we're going to look at that later in this lesson. And if they're in percentages, I can't see the raw data. So even though the class of 2008 may have had a higher percentage of something, I don't know how many students we're actually talking about. So there's some drawbacks there. All right, so we are done with part of our objectives. We were able to compare the strengths and weaknesses of a bar graph, and we were able to construct and interpret a bar graph. So what I want you to do is I want you to pause, and I want you to have an interaction. So with what we've done so far, I want you to summarize what did we just talk about. So summarize for yourself everything that we just did. I also want you to write down, what do you need to remember? So if you are asked to interpret a bar chart or create a bar chart or to talk about the strengths and weaknesses of a bar chart, what are the things that you're going to need to remember that you didn't already know? What visual will help you remember this? So if you need to draw a bar chart and label the different pieces that go into it. And what questions do you still have? So if there's anything that we talked about that doesn't make sense, that's where you'll write that down and talk to your CSG group tomorrow. So a pie chart. We are actually not going to construct pie charts because they are super intensive and we have technology that will do it for us. So we're going to focus mostly on interpreting pie charts. So a pie chart depicts categorical data as a percent of the whole. Okay? So always a pie chart is going to add up to 100% because we're talking about how within the data that I have does each piece fall. So we're going to look at that same data, class of 2008, class of 2009, and their time spent earning a degree, and we're going to answer those same questions. So for the class of 2008, the highest percentage of students took how long to graduate? So class of 2008, the highest percentage. So when I look at this, I can see that the blue is the biggest section. So I don't even have to look at these values to see that it took 6 years for a student to graduate from the class of 2008. That was the majority of the students. For the class of 2009, the highest percentage of students took how long to graduate. So when I look at this, I don't even have to look at the numbers. I see that the green is the biggest section, so less than 2 years. So by looking at these two next to each other, I can see that this class had a higher percentage of students take longer than this class, which had a higher percentage of students take 2 years or less. So what I can infer is that this class probably got a lot more associate's degrees, because very rarely do you earn a bachelor's degree in 2 years, whereas this class probably has more bachelor degrees because it took 6 years for the majority of their students to graduate. For the class of 2008, how many students took 4 years or less to graduate? All right, so if you remember, the pie chart is shown in percentages, whereas this is asking how many students. So I'm looking for a raw number. So I can't get a raw number just from a pie chart, but if you remember, there were 173 students in the class of 2008 and 179 students in the class of 2009. So for the class of 2008, how many students took 4 or less years to graduate? All right, so 4 or less, we're talking about this chunk of the graph right here. So we're talking about 29%, 7%, and 3%. So when I add those up, we're talking about 39% of the class of 2008. So I want to know what 39% of those 173 students are. All right, so in math, of means multiply. So I'm going to multiply 39%, and I can't type 39 into the calculator because the calculator thinks of percent as part of one whole. So I'm going to make that a decimal. So 39%, 0.39 and 39% mean the same thing, of 173. So I'm going to calculate, and I get 67.47. So 67.47, we're going to round because we can't have 0.47 of a person because there's probably some rounding that happened up there. So 47 would stay the same. So we're going to say about 67 people. So of that class of 173, about 67 of them took 4 or less years to graduate. So go ahead and pause the video and try for the class of 2009 how many students took 4 or less years to graduate. All right, so hopefully you saw that there was actually only one category because there were no students that took 3 or 2 years or less to graduate. So 30% would be 4 years or less of the 179 students. So we did 0.3 of means multiply 179, and I got 53.7, which that 0.7 says to go up, so I had about 54 people. Which class had a higher percentage of students take 5 years to graduate? So go ahead and pause the video and answer that question. So hopefully you were able to come up with the year 2009, because if you notice, 5 years is that dark green, and I can see that 29% versus 45%, 2009 had a higher percentage. Now, did they have a higher amount of people? We'd have to calculate to see. But since these are pretty close together, we can probably say that they did. But if this were 400 and this were 100, 29% of 400 people could be more than 45% of 100 people. All right, so this is just a chance to practice calculating using a pie chart and percentages if we want to know raw data. So I'd like you to pause the video and answer these 4 questions using this pie chart. All right, so hopefully you were able to get 960 if I had a $2,000 budget and I paid 48% of my money goes towards rent, which makes sense because 48% is a little less than half. So a little less than half of 960 makes sense. So I can always step back and use my practical thinking. 5,000, my rent would be 2,400. All right, if I have a monthly budget of 2,000, how much will I budget for fun and clothes? So if I notice, fun is purple and clothes is kind of that light blue. So I'm talking about 19% because I'm talking about this piece of pie right here. So 19%, 0.19 of 2,000 is going to be $380. And $950 would be if I had a $5,000 budget. So if you had any questions about any of those numbers, make sure you write a note so that you can talk about it tomorrow in your CSG. So a pie chart, what are the advantages? It's really easy to determine parts of a whole. So when I looked at that pie chart, I could tell that almost half my rent was going to, almost half of my budget was going to rent because I could see it was almost half of the pie. It summarizes a large set of data in a visual form, and it's pretty easy to interpret and understand. The disadvantages is I don't know exact values. So if I didn't know what my monthly budget was, I wouldn't be able to determine how much money I'm actually spending. They're difficult to make, trust me, because you have to use 360 degrees and divide that out, and it gets really confusing, so we use technology. And again, they can be really easy manipulated to say what you want to say. All right, so we've now completed 2 full objectives. I can construct and interpret bar and pie charts. I can compare the strengths and weaknesses of each statistical graph. So focusing on the pie chart, I want you to have an interaction. So go ahead in your notes. I want you to pause and I want you to summarize what we just talked about. Write down anything you might need to remember. If you need to draw a picture and summarize your data or your information, or what questions do you still have? So if something doesn't make sense, this is where you're going to write that down. All right, so the last thing we're going to do is we are going to talk about what makes some graphs deceptive. So I want you to look at this, and I want you to just analyze. So graph A, I have these monthly profits from October to March. And over here, I have monthly profits in graph B, also from October to March. Which company would you think is doing better? Which company do you think is not showing as much growth? Now what would you say? So go ahead and look at graph A and look at graph B. Pause the video and see if your initial reaction still holds up. So hopefully once you analyzed, you noticed that graph A in October had $14,000 in profits, and graph B had $14,000 in profits in October. Graph A in March went all the way up to $15,400, but in March, this is about $15,400. So what is the difference between these 2 graphs? Because they actually plot the exact same data. So what is it that made graph A look a lot more drastic and graph B look a lot less drastic? Well, hopefully you noticed that the scales. Over here, we were going by 500s consistently. So 14,000, 14,500, 15,000, 15,500, 16,000, 16,500. So we saw that consistency. Over here, it kept the same 500, but then it went up by 100s. So it made this growth right here from January to March look a lot different because that scale is not consistent. So a graph can be easily manipulated. If we don't take the time to analyze the scale, we're going to see higher profits when in actuality this is what they look like. And this happens all the time. And that's why one of my biggest objectives for this class is for you to become educated consumers of data. So when you see a graph, you're able to analyze it and really figure out if what they're showing is the truth. So one of the ways to misrepresent data is to change the scale. So in that case, it wasn't a consistent scale, but a lot of times they do use a consistent scale, but they make the scale really small. So instead of going up by 500s, they go up by 50s. And that's going to make a difference between 500 and 570, or 650 look different than a scale that goes by 100s. Or to make the data look less drastic. So if I'm trying to show my investors that we haven't lost as much money as we actually have, I'm going to make the scale really large because then it'll show less drastic change in the data. Alright, so what do you see here? So if you were to look at just this data of assists and steals, immediately which one are your eyes drawn to, and what does it look like? So my eyes are immediately drawn to assists, and it looks like the number of assists are a lot larger than the number of steals. Okay, well this is actually data from 2008 to 2009, where Dwayne Wade averaged 7.5 assists per game and 2.2 steals per game. So when I look at this, this looks a lot larger than 7.5 compared to 2.2. So let's fix it. Go ahead and pause the video, still using basketball. See if you can fix the graph. So hopefully you were able to realize that I could use the same size ball and just stack them. So I'm a horrible drawer, and especially on an iPad, but if you notice, this now makes the data look a little bit more reasonable. I'm not drawn to this huge basketball compared to this little one. I just stacked the same size on top. Now this isn't exact, but pretend like it is. You get the gist. So another way to misrepresent data is to use pictographs. So that's a pictograph, and you make one item scaled up that makes it look a lot larger. So to fix that, pictographs of the same size should be used, and each item should be stacked to represent more data. Alright, so when you look at this, what do you see? So I see this claim that massive increase in house prices this year, so 1998 to 1999, and I see that it looks like 1999 just blew up. The house prices increased drastically. So if you notice that this graph didn't start at 0. Now, it kept a consistent scale, but it didn't start at 0. So when I'm talking about 80,000, the difference between 80,000 and 82,000 looks very different than when I do start at 0. The difference between 80,000 and 82,000 is not that drastic. So another way to misrepresent data is to not start at 0, so that when you get to those really, really, really big numbers, you can see that there isn't very much difference when I do start at 0. Now, you can not start at 0 and use that broken graph notation. So you show that little break in the graph that we saw in the previous one about the monthly profits, and that's okay. When you show that broken graph notation, you're saying, hey, we're not starting at 0, but you have to show that notation in order to draw your reader's attention to that. Alright, so we have now talked about 3 things today, so I'd like you to pause the video, and I want you to have an interaction with the misleading data. So what's the important information that you need to remember? Is there a visual that will help you, and do you have any questions still? And lastly, I just like to put the vocab and the definitions. If you're a person who flashcards help you a lot, vocabulary is huge in this course, and so you're going to need to keep revisiting that. So if you want to make flashcards of these, some of you already addressed them over the summer, so you can keep working through that vocabulary. And I'll see you tomorrow.